Let's go ahead and solve the following triangle. We're given all the sides of this triangle, which means we're going to use the law of cosines. Let's go ahead and write out the law of cosines real fast. And the general plan for this problem is we want to fill in all the a, b's, and c's for each of these equations, and then solve for the angle inside cosine. So we're going to break this problem up into two pieces real fast. Solving for this equation, we'll call this 1, and solving for this equation, we'll call this 2. Plugging in the values for equation number 1, we'll get the following. This is going to be 10 squared is equal to 12 squared plus 16 squared minus 2 times 12 times 16 times cosine of A. Simplifying this one time, we'll get 100 on the left is equal to 144 plus 256 minus a 384 cosine of A. Solving for cosine of A, we get 300 divided by 384 is equal to cosine of A. Evaluating this using our inverse trig functions, we're going to evaluate cosine inverse of 300 divided by 384. This is going to be equal to A, which is approximately equal to 0.6741 rads. Whoops, it seems like my voice recorder wasn't recording, and so let me go ahead and state that, again, this is about equal to 38.62 degrees, and this is going to be our angle A. So now what we want to do is we want to go ahead and evaluate our second equation along the same lines. We're going to plug in what we know for B, A, and C, and then solve for cosine of B. So here we're going to get 12 squared is equal to 10 squared plus 16 squared minus 2 times 10 times 16 times our cosine of A. Simplifying this, we'll get 144 is equal to 100 plus a 256 minus 320 times cosine of A. Solving for cosine of A, we'll get 212 divided by 320 is equal to cosine of A. Again, using our inverse trig, we want to evaluate cosine inverse of 212 divided by 320, and this is going to be equal to, oh, sorry, I just realized that this is not our angle A, this is our angle B. Well, our angle B then is going to be equal to about the following. 0.8466 rads, which is approximately equal to about 48.5 degrees. Since we know the angle A and the angle B of our triangle, we know two angles, and so the third angle has to satisfy the following equation. A plus B plus C is equal to 180 degrees. Therefore, angle C is equal to 180 degrees minus A minus B, which we mean C is then approximately equal to 92.87. Now let's look at another example of solving a triangle. In this case, we don't know whether we want to use the law of sine or the law of cosine, so let's just go ahead and look at the information given. Here we're given an angle C and also an opposite side C, which means it would be helpful to use the law of sine here, since we have one complete side. For example, if we wanted to find angle A, then this would be equal to sine of A divided by A. Plugging in what we know, this is going to be sine evaluated at 52 degrees divided by 50 is equal to sine of A divided by 65. Therefore, sine of A is equal to a 1.3 times sine of 52 degrees. Evaluating sine at 52 degrees, we're going to get approximately out 9.86627. Simplifying this, this is about equal to the following. 1.28. Since this is equal to sine of A, we come actually to a contradiction. Since the range of sine of A is bounded between 1 and -1, and this value falls out of that range, there can't exist a triangle that meets all these conditions. So the solution is this triangle does not exist. Let's use the law of cosines to determine the indicated side x here. Again, let's first just write down what the law of cosines is, and then pick out the equation that we need to use. Here, we're given side A, we're given side C, and our x would be equal to side B. Since we already know the angle B, we want to go ahead and pick out the second equation here. We get b squared then is equal to 24 squared plus 30 squared minus 2 times 24 times 30 times cosine evaluated at 30 degrees. Then our b is going to be equal to the square root of 576 plus 900 minus 1440 times the square root of 3 divided by 2. Simplifying this, we get our b is going to be equal to the square root of 228.9234, which gives us that this is approximately equal to 15.13021. Let's go ahead and look at one more problem. In this problem, we're looking at a parallelogram with sides 3 and 5 and an angle of 50 degrees. And what we want to do is we want to find the lengths of the diagonals of our parallelogram. So by definition, a parallelogram is a quadrilateral who has two sets of sides, each of which are parallel. So here is a picture of a parallelogram. Let's label this side with length 3, this side is length 3, and these two sides have length 5, since in a quadrilateral, our parallel sides have equal length. Now, another fact we know about parallelograms is that the sum of our angles have to sum up to be 360 degrees. So let's call this angle 1, call this angle 2, call this angle 3, call this angle 4. We know angle 1 and angle 3. These are both going to be 50 degrees. Which means we can simplify this down to be 260 degrees is equal to theta 2 plus theta 4. And again, for our sides of our parallelogram to be parallel, theta 2 has to be equal to theta 4, which means 280 degrees is going to be equal to 2 times theta 2. This gives us theta 2, this should be 260. Theta 2 is equal to 130 degrees. Now we want to find this diagonal here, and we formed a right triangle from this diagonal here, and we're going to apply the law of cosines to find what this length is. By the law of cosines, we'll get the following relation that L squared is equal to 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of theta 2, which is 130 degrees. Therefore, L is going to be equal to the square root of 25 plus 9 minus 30 times approximately a negative 0.6427. This is approximately equal to the square root of 55.2836, so on and so forth, which is approximately equal to 7.4352. So this is the length of one of our diagonals. I'll leave finding the other length of this diagonal here as an exercise.